Hello, my name is Manu Cohen Yashar, and today I'm going to speak to you about application security. Today we'll be covering what is application security after all, what is threat modeling, how do you do input validation, authentication and authorization, cryptography, secure communication, configuration management, logging and auditing, and exception management. There's lots to talk about. So, before we dig in, what is security after all? Well, if we look at the theoretical definition, security is a degree of protection against any danger or threat. Well, that is nice, but again, pretty theoretical, because we cannot protect against anything, against things we don't know. Well, to be more practical, we look at the practical definition, and that is, security is a degree of protection against reasonably predictable danger or threat. And that means we have to plan for security. And it also means that there is no absolute security. You cannot totally secure your application against things you don't know. You have to plan for what you want to secure and what you won't secure. So, security is quite a holistic subject. It means that anything should be considered. Well, we can begin with the infrastructure. Infrastructure means that firewalls, operating system, databases, etc., they all should be secured. It means that you have to take security into consideration when you buy such infrastructure. People tend to believe that if you buy the best firewall in the market and you plug it in, that's it. You're secure. But unfortunately, this is not the case. If we look at the other edge, that's human security, it means that human have to be put in the equation as well. You can buy as many firewalls as you want and plug them in, but if some user, for a certain reason, political or money or whatever, well, he decides to expose the information he's exposed to. He can memorize things he saw, he can plug a stick and copy some files, etc., etc. And then he goes and exposes that information to an unauthorized person in the media or whatever. That's it. Your information is exposed. No more application security for you. So, of course, there are regulations and rules how to protect your data and how to work with your people, etc. That is out of the scope of this presentation, but at least you have to know that it is another aspect of your actual application security. And on the middle, we have the actual application security. The application is the only layer who actually knows what's going on. The application, well, implements use cases. It deals with the data, etc. It does something business-wise with your data. And it is the only layer who knows that. So this is where you'll be able to protect or secure those use cases. For example, let us take a simple bank app. Well, these apps authenticate its user using username and passwords credentials. Well, that's normal. And for example, the username is the bank account number. Well, the username is pretty easy to guess. So let's say we have a bad guy, an attacker, who guesses those bank accounts, those usernames, and then he tries to authenticate using false passwords. Well, that's easy, because false passwords are easy to guess. And then what happens? The application will block the account after 3 or 5 or whatever attempts to log in. So now we can automate that. We can guess all the bank accounts and block all the accounts within hours. Now, legitimate users will try to log in, but their account is blocked. So they try to call the help desk. The help desk is designed to handle 3, 10, maximum 20 calls per hour, but now we have 10,000 calls per hour, and the help desk crashes. So people will try to find their best contacts in the bank to just ask what's going on. And this can cause the whole bank to crash. Now, what happened here? The use case of blocking an account should be happening in average 3 to 10 times per hour. That's normal behavior. But 10,000 times per hour or 100,000 accounts per hour, that's abnormality. That's not normal. And the application should know that. Of course, there are many ways to protect against that scenario. Again, all this would be done by the application. So that's an example of the application security. So, how do you actually do that? The first thing we have to do is threat modeling. Most people, unfortunately, they remember that there is something called application security when they have to ship the application. Unfortunately, when they get to test the application and find about its application security breaches, that's too late. It's very expensive to deal with those threats and breaches, and usually it's impossible to fix them. A more economical perspective is to go and to look at the application at the design time. And then you'll be able to find the problems and fix them before you even implemented the application. So that's the most economical thing you can do. Plan for security and do it on the design phase. Now, how do we do that design? Unfortunately, we cannot secure anything, and we have a limited budget. We cannot spend infinite amount of money on security. You could if you want, because you can always protect against something else. You can always find another threat to mitigate. So you can spend infinite amount of money on security, but management, they don't like to spend so much money. They will give you a limited budget. The question is how to spend that budget in the most intelligent way. And to do that, we do threat modeling. What we actually do is we look at the design of the application and we look on our assets. We identify the things that are important to us. And then we identify what are the threats that are threatening those assets. Looking at the threats, we can rate them, and we rate them using risk management. We just look at the risk. How many people will be affected by the threat? How easy it is to mount this attack? Is it FBI, CIA? They only can mount the attack because they have the money and the equipment and the knowledge, etc. Or can anyone at home with a personal computer can mount the attack? Well, of course, these are different risks. And if only one user will be affected from this threat, okay. It is sad, but it is only one user. But if all users will be affected, well, that's another issue. So here we get the risk, and we can rate those threats according to the risk. And then we look at the most important threats to us, and we find the mitigation. We plan for the mitigation, and we choose the best mitigation in terms of money, budget, technology, etc. that will mitigate this threat. This way, we can come to the management and say, we are going to secure against this. We are not securing that, and it will cost us this amount of money. This way, we stay in control, and that's very important for management. If we don't stay in control, if we don't come with that plan to management, well, the result is that we will not do security at all. To do actual security, as I said, it is a holistic issue. We have to take security into consideration throughout the life cycle of the application. We don't have to do it just on the design time. We have to do it in the requirements. We have to know what security specifications and standards we have to obey to. And then, of course, we do the design, threat modeling, etc. And while coding, we have to do coding best practices, and we have to do security code review, etc., etc. Then we do testing. We do static testing on the actual code. We do dynamic testing. We do penetration testing. Then we go and deploy the application. And before we actually deploy the application, we'll look at the threat modeling we wrote and defined on the design phase, because as you always know, the actual product that you are deploying is pretty different from the product you designed, because things change throughout the life cycle of the application, and we have to verify that the actual product that we are deploying really obeys to the design and the threat modeling we defined on the design phase. And then we do support, because we all know that we are people and we have bugs, and there will be security issues, and we'll have to deal with them. We have to provide the security patches, etc., etc. So security is there throughout the life cycle of the application. Microsoft introduces the SDL. It defined a methodology how to implement security throughout the life cycle of your application, and I really recommend to read about the SDL and to implement it on top of your methodology. Now, okay, let's go to practical stuff. So let's do input validation. That's the first thing we do concerns application security. And input validation is so easy, but it is so powerful. If you look at attacks statistically and we analyze them, we see that a very large percentage of attacks, today's attacks and future attacks, really originate in malicious input that is provided to the application. Well, we can mitigate those attacks very simply by validating input and blocking malicious input to the application. That's it. So simple, so powerful, so economic. But to do validations, we have to find the right strategy. The best thing we can do is to use a whitelist. That means if the input has a pattern, it obeys to a certain pattern, it goes through a certain pattern, we can say that anything that follows that pattern is okay and we let it in. But anything that doesn't follow the pattern is out. For example, if we have an email, an HTTP address, a file path, a phone number, etc., etc., they all have a pattern that we can check. That is a whitelist. We can use regular expressions, we can use range validators, and we can write our own custom validators that check for patterns. If we don't have a pattern, if it's just free text and we cannot define such pattern, then we have to look for the blacklist. Blacklists are a list of malicious input that we know about. For example, the select star from table where 1 equals 1, that's the most famous malicious input for SQL injection. We look for things similar to that, and then we say, hey, well, that's malicious, you're out. The problem is that we don't know tomorrow's attack, and we don't know the malicious inputs of tomorrow's attack, so we cannot protect against anything. It is a very limited way to do input validation, but maybe that's the only thing we can do. We can also say that this input was not properly validated because we don't have a pattern, so we'll look at that input with care. We will not allow anything to run, we will not allow anything to be scripted or etc., or anything etc., using the information that we validated only with blacklist. Another thing we have to say here, that validation can occur on the client and on the server. But on the client, it has nothing to do with security. It has to do with user accessibility and the user interface. That's it. So if a user forgets a certain info and in a required field, and you get that on the client, you tell your client, hey, I want to help you, and please provide that required field. That's only for you, but it has to do nothing with security. On the server side, we'll have to validate again, because we have to assume that a malicious, an attacker, he can always bypass client validation. So client validation cannot help us in terms of security. We have to do a security input validation only where we trust ourselves, and that is on the server only. And then we do authentication and authorization. Most systems, they need to know who is the actual user and what can he do. Authentication means who are you, and authorization means what you're allowed to do. To do that, we can use two different typologies. One is role-based identity and the other is claim-based identity. In role-based identity, all we have is a user, which means a name, an identity which has a name, and this identity has roles. It is a member of certain groups, and it has certain roles, and we allow certain actions according to those roles. That's it. You are X, your name is John, and you are a member of the employees' roles, or you are a member of the administrator roles, etc., etc. That is it. It is very simple to implement, and we have various infrastructures that do that for us, like Active Directory, Authman, ASP.NET membership provider, etc., etc. So these infrastructure, they preserve the information according to which we identify the actual user and we provide the roles to it. After that, that information is put in a principal object, and that is put in any thread. So that is a security context. So throughout the code, it is accessible to us, and we can ask who is the actual user, what is its name, and what roles he is member to. That is nice. That is very simple, and the application is in charge to implement authentication and authorization. Unfortunately, in distributed scenarios, that's not enough. We need something else. We need something stronger. And for that, we have claims-based identity. The infrastructure that allows us to do that pretty easily are WIF, Windows Identity Framework, ADFS, 2.0, Active Directory Federation Services, or AppFabric on the cloud, Windows Azure AppFabric Access Control Service. How does it really work? So let us say we have an application. The application now, it will not be responsible for authentication anymore. It exposed that, it takes that responsibility to another entity, and that entity is called the STS, Security Token Service. Now, the first thing that the application has to do is to establish trust with that external entity. So, during this establishment, the STS and the application, they exchange keys, signing and encryption keys, and the metadata. The metadata, in the metadata we write how will a token that will be produced by the STS, how will it look like? What information will be there? The STS, what the STS does is very simple. It generates token. It creates tokens. And in the token, it puts claims. Claims are very simple pieces of information. That's it. Now a user comes to the application and says, hey, I want to use you. The application says, excuse me, if you want to use me, you have to provide me with a token. A token from an STS I trust. So the user goes to the STS. Of course, this policy can be put on design time, so the user don't have to go to the application and ask for the policy. But then the user, when it knows the policy, it knows where to find the STS, it goes to the STS and says, well, I need to go and get the token. So the STS says, fantastic, I'll provide you with the token, but please tell me who you are. So the STS does the authentication. The user provides credentials, and the STS provides a token. In the token, it puts all the information, all the claims that are required. The STS actually asks an identity provider, and that's the Active Directory, an identity provider who knows about this user, which claims to put, etc., etc. So now the STS provides a token, the user has a token, and the user supplies that token to the application. The application now verifies the token, it verifies its digital signature, and it opens its cryptography, because the token is encrypted with the key, with the public key of the application. This public key was provided to the STS. On the other hand, the public key of the STS is provided to the application, using which the application can verify that the token really originates from the STS using its digital signature. So now the application opens the token, and it can decide whether to allow or deny access and to provide service. Now those claims can hold much more information than roles we had in role-based identity. You can put there, you can put claims with your age, your favorite color, actions you were allowed to do, etc., etc. So the richness of the token can allow the application to be more efficient and to have all the information it needs also to do its business, and not only to do authorization. Now, this was a very simple scenario, but claims-based identity, it is very, very good for federated scenarios. And this is where role-based identity actually fails. In federated scenarios, we have an application who have to give service to clients from different organizations. In role-based identity, the application is responsible for authentication, not the STS. So because the application is responsible for authentication, it has to create users, identities, for all its actual users. Now let us say we have users from different organizations. For example, we have users from Microsoft, and we have users from the US government. It doesn't really matter. The application has to create identities for all of them. Now that's very difficult for the application because it's difficult to manage. If a certain Microsoft employee was fired, the application has to know about that, because the application has to deny access from that moment on. And that's not easy to synchronize Microsoft employees with my users. I'm just an external application. On the other hand, the users themselves, they don't like to have identities in all the applications they use, because all those applications, they have credentials. So I, as a user, I have to remember so many credentials. Well, I'm just a person, I'm a human being, and I don't remember so much. So what I will actually do, I will use the same credentials throughout all the applications I use. Now, if a certain application did not do application security properly, these credentials might be stolen, and now they can be used in my bank or in any other application. So I don't like that very much. I don't like to spread my credentials throughout the applications I use. So it's a lose-lose situation. The application does not want to manage your identity, and the user does not want to create those identity throughout the application he uses. So we need something else, and that is claim-based identity. Here, the user will manage his identity only in one spot, and that will be the natural STS for him. That's it. But the application will trust, or the application will use an STS which it trusts, but this STS will trust other STSs, for example, the natural STSs of the users. And using this trust, the user will be able to authenticate against a single STS, and that's his natural STS, but still use applications who just trust this STS. That's it. How it goes? Well, a user goes to the application, he gets a policy, and this policy says, well, please authenticate against my STS, but this STS, it trusts the user's natural STS. So the user can authenticate against his natural STS. Well, he is provided with a token. This token is provided to the application's STS. And as we said before, the application STS trusts the user STS, or his natural STSs. For example, my application STS trusts the Microsoft employees STS. So now the application STS can map the token that was provided from Microsoft's STS, from the natural user's STS. It can map this token to another token. This token is provided back to the user, and the user can provide that token back to the application. Now, the application does not know anything about that process, because it received the STS it needs from the token it needs from the STS it trusts. The application is happy, but the user did not really authenticate against the application STSs. It authenticated against his natural STS. So everybody's happy. This could not be done in role-based identity, and this is why claim-based identity is so powerful in the distributed world. Well, now we've done authentication and authorization. Let's go and do some cryptography. Well, cryptography deals with several problems. The first problem is integrity. That means, how do I know that certain information was generated in the source I thought it was generated at? How do I know that I get some information and that and the source of that information is really the source I assume it is? And how do I know that this information was not changed, was not altered on the way to me? So to do that, we use digital signature. Another problem, a very traditional problem, is how do I hide information from people I don't want to have access to my information? And that we do with symmetrical encryption. This is the same encryption we've done for many years. We have a key, and using that key we close and open. We encrypt and decrypt that information. Of course, we don't use the algorithm that were used 2,000 years ago, but we use the same principle, which is we have a single key to encrypt and decrypt. There is another way to encrypt data using a public and private key, and that's called asymmetric encryption, but that is not used to actually encrypt a whole bunch of data, because it is very limited in performance. So we use asymmetric encryption just to exchange keys or to do digital signatures. And so after exchanging those keys, now we know that the key was exchanged safe, and now we can do symmetric encryption and encrypt the information. Let us do a little demo and see how do we do encryption in .NET. So fortunately, .NET provides us with lots of API to do everything we need in application security, and one example is encryption. So the scenario we have here is the client wants to communicate with the server, and it wants to do this communication securely. So what it will do, it will generate some information. It wants to send that information to the server. To do that, the client wants to encrypt the information to protect it. But again, when we speak about encryption, we speak about managing keys. It's the same thing. When you speak about encryption, you have to talk about key management. How do you protect your keys? So what the user does, it will create a key, and then it will create a public and a private key, and it will send the private key, the public key, to the server. The server knows the public key. The client knows the client knows the public key of the server. The server has a public and private key. The client knows the public key of the server. The client will generate his own key, and he will encrypt the key using the public key of the server. Now he sends this key to the server. Only the server can decrypt the actual key using his private key. Now the client is sure that the key was safely transferred to the server. Now he can encrypt the actual information using the key it generated. The server will get that information. The server decrypts the key, and using that key, now it can decrypt the information. Let's see how do we do that. So, the public and private key are in a certificate. We'll speak about certificate in a minute. So this is the information, hello world. And now the client creates a key. We use a random number generated provided by system.security.cryptography, and we create a key. Now the user encrypt that key, and you can see how easy it is. Let's go to encrypt data. And as you can see, all we have to create is a crypto stream to put our information in a memory stream that will be put inside a crypto stream, and just flush the stream, and that's it. So we created an encryptor, and we flush the stream, and that's it. We have encrypted data. As simple as that. Now the user has the encrypted data. What it will do, it will take the key and it will encrypt the key using the public key of the server. So let's go to encrypt key, and as you can see, what the actual user does, it fetches the certificate, it takes the public key from that certificate and using the RSA crypto service provider, it encrypts the key. So now the key is encrypted using the public key of the server. Well, now this key can be sent to the server. We can do that in a mail or whatever. So let's assume the key, the encrypted key, reached the server. Now the key should be decrypted. So the server will decrypt the key. And here we do decrypt key. Again, we fetch the certificate from the certificate store. We take the private key, and using the same RSA crypto service provider, we decrypt. Now the server has a decrypted key. So using that key, he'll go and decrypt the data. Again, we use the same crypto stream, but now we create a decryptor, and we flush the stream, and we get the actual data decrypted, and that's it. We're happy to go. So the information was hello world. Here, let's see if after all this scenario we get hello world, the server message. Yes, hello world, we've done encryption. In this demo you saw how easy it is to implement symmetric encryption and asymmetric encryption using API provided by system.security and system.security.cryptography. And this is just an example of the rich API provided to us by .NET and Microsoft to implement application security. Okay, let's continue. We spoke about secure communication, and we saw how to implement it in hand, by hand. But we can use API provided by .NET to actually use a built-in secure communication. We can do SSL. We can do WCF security using WS standards, WS security standards, etc. And we can use negotiated streams. Again, all this is provided by .NET to us. Eventually, it all implements the same idea. And this is the idea of SSL. So how does it really work? First, we have trust between a client and a certificate authority. Well, we all trust a certain certificate authority. We have a certificate using in which we have the public keys of certificate authorities built in any machine. When we buy a machine, we have those in hand. So the trust is already there. If we want, we can establish this trust manually to other certificate authorities. Now, a server, a server creates a private key, and it has a public key complying it. So we have a server who has a private key and a public key. The server creates a certificate request, and it supplies the public key to the CA, to the certificate authority. The CA verifies that the server is really a good server, it's a good company, it is really it, etc., etc. So now it wraps that public key with some other information, like the name of the public key, the name of the company, etc., etc., and it wraps that in a certificate called X509 certificate, and it digitally signed that with the private key of the CA. This key is provided back to the server. So the server has that certificate. When a client comes to the server and says, "Hi, I want service," the client wants to authenticate the server. The client wants to know that it is really communicating with the real server, with the real bank, with the real company. So it asks the server, "Please provide me with your certificate." So the server does that. The client contacts the server, and the server provides the certificate to the client. Now the client, it has trust with the CA. It has the public key of the CA. So it can verify the digital signature of the certificate which was just provided. If the digital signature passed, it means that this certificate was really originated by the CA. So if I trust the CA, and the CA tells me this is the real server, this is the real company, I assume that I am speaking with the right company. I am happy. Now the client authenticated the server, and that's before the server authenticates the client. Now what the client does, it generates a random key, and it encrypts the random key with the public key which was just provided with the certificate. It's the same idea that we saw in the demo. So now this random key encrypted with the server's a public key, it is provided back to the server. The server can decrypt that information because it has the private key, and now the server and the client, they exchange keys securely. Now with that key, the server and the client, they can establish a secure channel, and everything will be encrypted and digitally signed on that channel, and that is SSL. Okay, so we communicated securely. Let's speak about configuration. Configuration holds sensitive information, and thus it should be protected. For example, in your configuration file, you might hold connection strings to your database. The database holds the data. The database is the holy grail. The data is the most important things on earth. It's the most valuable things on earth. So you want to protect that. If I have the connection string, I have connection to the data. So I want to secure that connection string. And that is only part of the sensitive information that you might find in the configuration files. You might find business rules. You might find all sorts of information that actually, or policies that actually manages how your application is actually running. So this information should be secured. Fortunately, system.configuration provides us with the capabilities of protecting that configuration file. We can encrypt and decrypt configuration sections, and you might consider to do that. ASP.NET has a tool that uses system.configuration capabilities, ASP.NET Reg IIS, again, that encrypts and decrypts configuration files. Of course, you can do your custom thing, but you just have to verify that this information is secured. Of course, this information must be audited, and you must be sure that you know who accessed that data, when it was changed, by whom, etc. And if we look at security regulations and policies, they want to see those logs, and they want to verify that you are absolutely sure that this configuration file was not changed but by an unauthorized person. After you secured your configuration, we're happy to speak about auditing and logging. Usually people log problems. There is an exception, so let's log the exception. Of course, it is very important, and you should continue to do that. But applications need to identify normalities and abnormalities. The application should know that its use cases are in an abnormal state. Something wrong is happening. We are blocking 10,000 users per hour. If we go back to the example we spoke about in the beginning of this talk, this should not happen. Now, how do I identify abnormality? To do that, I need to identify normality. And to identify normality, I need to log certain information. So you should log and audit important aspects of your use cases, and then you should look at those logs, analyze those logs, and verify all the time that you are in a normal state. Of course, when you identify abnormality, you should do what you designed to do. That's a question that should be answered in the design phase. To do auditing, there are certain infrastructure that several infrastructures that you can use. You can use Log4net, you can use the logging application block, you can use event tracking for Windows, ETW, you can use event logs, and many, many more. The thing is, log important aspects, analyze it, and verify all the time that you are in a normal state. Now, when we speak about logging, we have to speak about exception management. When something wrong had happened, something bad happened, and an exception was thrown, an exception is a very powerful way to expose the information to you, to this developer, to the administrating, saying, hey, this happened, please fix that and let us continue. It is a very, very powerful tool for error management. But unfortunately, it might be too powerful. When an exception is exposed to the actual user, usually the user does not know what to do. If my mother gets to see an exception saying that a certain SQL statement failed because a certain SQL type mismatch occurred, etc., etc., or a connection string is wrong, or you name it, null reference exception, my mother knows nothing to do about that. It cannot do anything practical about that. And, well, she calls me and says, hey, something wrong with my app. That's a lose situation for her. But the attacker, the hacker, he is very happy to learn about intimate information of your app. So the attacker, the hacker, is very happy to get those exceptions and learn from them how to attack your application. So we get a lose-lose situation here. The user is unhappy, he knows nothing to do with that information, and the attacker is very happy. Lose-lose situation. That means that you have to catch all the exceptions of your app, sanitize them, and then provide the user with a simple error message that might be helpful for him. Tell him what to do. Maybe he has to just contact the administrator. Maybe he can do practical stuff that can help your app, but never expose intimate information to the actual user. Of course, your exceptions, your real exceptions, must be logged, and to allow the administrator or the developer later on to sanitize, to find out what went wrong, and to analyze and maybe to fix the problem. So with that we wrap up, and we see that application security has many aspects, and you have to do a lot from the beginning of the application lifecycle to the end to take security into consideration and to implement various aspects of application security. We're very happy that .NET provides us with the tools and APIs to do so. So do security from the design, use a methodology to do that, use the SDL, learn about application security, and continuously continue to learn more and more, because there are always new technologies, new aspects, new attacks, new threats, new mitigations, and implement application security in your application. Read more, enforce the SDL, do threat modeling, and do application security testing to find out that your threats were really mitigated. There are many resources to read about application security. You can go to the OWASP site, Open Web Application Security Project. They have lots of information there. You can read more about the SDL, about threat modeling, and there's tons of information in MSDN about the APIs and tools that Microsoft provides. I hope you enjoyed the talk, and I hope you will implement application security in your app. Thank you.